Inside every single one of your cells, right this very second, there's a war going on. It's a silent, totally invisible conflict that's being fought every moment of every day to protect the most valuable thing you will ever own, your genetic code. So let's dive into this microscopic battle that literally defines who you are. So get this. Your DNA, the very blueprint that makes you, gets hit up to 1,000,000 times a day. I mean, that sounds completely impossible, right? How does life not just collapse into a total mess of errors? Well, that's the incredible story we're going to unpack right now. Okay, so to really get a grip on this war, we first have to appreciate what's actually being defended. Your DNA isn't just some abstract code. It is the master plan for everything your body does, from breathing to thinking. And its most basic, most critical job is simply to get copied. This quote from biologist Francois Jacob, it just nails it. The whole point of life, when you boil it right down, is to make more life. And every single time, that starts with copying the DNA. But here's the catch. This super important process, it's also where all the danger begins. So let's zoom in on the actual machine at the heart of all this. Your cells are dividing constantly, and every time they do, they have to copy your entire genome, all 3 billion letters of it. The whole process is called DNA replication, and it happens at a speed that is truly, truly mind-boggling. I want you to just try and imagine this. You're trying to type out a book with 3 billion letters, and you have to do it billions of times a day, and you have to do it almost perfectly. That's the insane challenge your cells face. Speed is absolutely essential for life, but it comes with a price, creating this constant tug of war between getting the job done fast and getting it done right. And your cells have these amazingly clever tools, like these things called sliding clamps, which, by the way, literally hold the DNA copying enzymes onto the strand to keep them from flying off the rails. But even with incredible safeguards like that, mistakes, simple typos in the genetic code, they're just unavoidable. Okay, but here's the thing. Simple copying errors, that's just the tip of the iceberg. Your DNA isn't just sitting there in some quiet, protected library. Nope. It's on the front lines, taking a constant beating from the outside world and, believe it or not, from inside your own body. And this is where the scale of the problem just becomes mind-blowing. We are talking about up to 1,000,000 damage events in a single cell every single day. Now, multiply that by the trillions of cells in your body. The number is just, wow. So what on earth is causing all this chaos? Well, the bad guys are literally everywhere. The UV light from the sun can physically bend and break your DNA. Chemicals in things like smoke or even in some of our food can attack it. Even the normal process of making energy inside your cells creates these things called reactive oxygen species. You can think of them as molecular exhaust fumes, and they wreak havoc on your genome. And sometimes the DNA molecule just falls apart on its own. It's a really hostile world out there for such a delicate molecule. So, with all this chaos, how is life even possible? Well, it wouldn't be, not without an incredible defense system. Your cells have this highly specialized army of proteins, let's call them the microscopic repair crew, that works 24/7, patrolling your DNA and fixing damage the second it happens. All right, first up, let's meet the team. I call them the proofreaders. Their whole job is to trail right behind that high-speed copying machine and catch all those little typos we were just talking about. Now, the sciencey name for this is mismatch repair, or MMR. But honestly, just think of it like the ultimate spell checker for your genome. It scans the brand new DNA strand, checks it against the original, and if it finds a mismatch, like a G where a C should be, bam, it flags it for an immediate fix. And this is what it actually looks like, right down at the molecular level. You can see this specialized protein complex, our little proofreader, is literally clamped around the DNA right where that typo is. It can actually feel the wrong shape, and it just latches on to kickstart the whole repair process. Pretty cool, huh? Okay, so typos, we've got that covered. But what about real physical damage, like the kind of nasty stuff UV light does? For that, you need a whole different kind of specialist, the damage control crew. This system is called nucleotide excision repair, and it's basically like a microscopic road crew that finds a pothole in the DNA. It doesn't just try to smooth it over, no way. It identifies the messed up section, chops out the whole chunk, we're talking maybe 30 letters of code, and then it perfectly rebuilds a new patch using the other, undamaged side as a template. So we've dealt with typos, we've dealt with physical damage, but what happens in a true code-red worst-case scenario? A catastrophic break that slices right through both strands of the DNA. This is a 5-alarm fire for the cell, and it calls in the emergency response team. And this is really the crucial part. The cell has two totally different game plans for this kind of emergency. On one hand, if a perfect backup copy of the DNA is nearby, which usually happens right after the DNA has been copied, the cell uses a process called homologous recombination. This is the perfectionist. It's slow, it's meticulous, and it uses that backup to make a flawless repair. But what if there's no backup? The cell can't just wait around. It uses a different strategy called non-homologous end joining. This is the surgeon. It's fast, it's frantic, it's all about saving the patient. It just jams the two broken ends back together to stop a total catastrophe. Sure, it might be a little messy, maybe a few letters of the code get lost, but it saves the chromosome, and that saves the cell. So you can see this whole system of proofreaders and road crews and surgeons. It's just unbelievably important. So what happens when just one tiny gear in this massive machine breaks? Well, the consequences can be absolutely devastating. Let's take a real-world example, a heartbreaking genetic disorder called Fanconi anemia. In this condition, some of these specific repair proteins are broken. That one tiny defect means the cell can't fix a certain kind of damage. And as you can see here, that damage just builds up and up and up, eventually leading to bone marrow failure and a huge risk of cancers. It is a terrifyingly clear example of how one broken link can make the whole system come crashing down. And look, Fanconi anemia is just one piece of the puzzle. It turns out that defects in all these different repair systems are linked to a whole laundry list of terrible health problems. A broken proofreading system is a classic sign of many cancers. Flaws in other repair crews can lead to conditions that look like rapid aging, or cause severe problems with the immune system, or even lead to brain diseases. It just hammers home how critical this constant, tireless maintenance really is for keeping us healthy. So the next time you think about your body, don't just picture some static machine. Picture a dynamic, bustling city with trillions of tiny workers constantly patching roads, correcting documents, and putting out fires, all to keep you going. And it all leads to this really profound question. What does it tell us about the nature of life itself? That its survival depends not on being perfect, but on being endlessly, brilliantly, and tirelessly good at fixing itself.